Hello everyone, my name is Roy Jafari, and in this video I'm going to teach you about classification algorithms. Classification algorithms are perhaps the most applied and famous techniques of machine learning and data mining. Perhaps there are so many of different classification algorithms out there, but what's interesting about all of them is that the foundational idea and the basic functionalities of all of them are the same. So in this video, I'm not going to really help you become masters of classification algorithms, or for that matter, teach you one classification algorithm. But what I'm going to do is to create a basic and foundational understanding of what are classification algorithms and what they do for us. So we are going to be using decision tree as an example of classification algorithm. There's so many different algorithms, but I believe decision tree is visual enough for you to sort of start understanding it better. And once we develop that understanding of classification algorithm in a more abstract way, we are going to apply it in a data set. And once I describe the abstract version of what classification algorithms are and then apply it to a real data set, by the end of this video you will have a pretty good understanding of what classification algorithms are. So let's get to it. So when we want to apply a classification algorithm, one of the things that we need to have is a data set that has a specific criteria. This data set needs to have a set of independent variables or predictors, and also the data set needs to have label or dependent variable or target variable. So the goal of a classification algorithm is to somehow find a relationship between the independent variables and the dependent variables. So find a relationship between the predictors and the target. So basically what a classification algorithm does is to see if there is any pattern among and between the independent variables that has the capability to predict the label of the data object. So once you find those patterns, the classification algorithm in any of those different algorithms sort of package this pattern that it has been found, and then gives you a trained model or a trained classification algorithm, and then you can run the new object by the trained model and sort of get an idea of what this new object is gonna be looking like as far as the label based on the classification algorithm. Pay attention, when you have a new object or new data point, you have to have all of those predictors or independent variables, their value. You need to have their values, and then once you have the values, you can run by those values by the trained algorithm, and then the trained algorithm relies on the pattern that was found in the data to predict the label, to tell you some idea about the new object's label. Sometimes the classification algorithm will pop out the label that it suspects the new data object to be, or sometimes it gives you probability. It depends on the mechanism of the classification algorithm. Okay, so let's come to our Jupyter Notebook and get introduced to the data set we're going to be using. So the data set we are using to showcase a classification algorithm problem is the data set of 115 couples with their corresponding if they got divorced or not, and their answer to 57 questions. So basically we want to see if we can find a model that based on the questions these couples have answered, to see if we can predict if they're going to get divorced or not in the future. So a pretty interesting case study. The data set, I found it on kaggle.com. This is the link if you want to get to the source of the data. We're going to need some packages to work with the data. So I import these modules, and then this is my data. I'm reading it with pandas. you can see you have 54 questions and one label, divorce or not. The shape of our data is 170, so we have 170 couples, and we have 54 questions and one label. And I'm going to change the labels from 1 and 0 to divorce or not. So I apply a lambda function. Whenever it is 1, I call it divorce, and when it's not 1, which is 0, it's not divorce. I just wanted to make it more like a label than number. So I do that, and then my data frame now it's divorce or not divorce. So each of these questions, Q1 to Q54, also it's just a question. So we want to know what these questions are at some point. We'll see, we'll get there. So it's recorded in another data frame, in another data set. And all of them, are here, but there is an attribute ID, and it's almost the same as the index. So I'm going to go ahead and change the attribute ID with Q1. I'm going to adding a Q1, Q2. So I want to make it similar to the attributes of the other data frame. And then I set that as an index. So this is my the database of my question. So, in the future, when I say, okay, I want to see what question 18 is, for example, I can come back and reference to this data frame. So that's all there is to it. So we spend a little bit of time to get to know our data. We use the function describe. We'll see all of our data is from 0 to 4 as expected, and there is mean and standard deviation differently across these questions, except for the divorce or not divorce, which is expected because it's a label, it's a string. So we create our decision tree. So here it goes. Once we start applying data mining algorithms such as classification algorithm, most of the time what that means is you prepare your data in a way that the classification algorithm can make sense of it, and the rest of it is done by the classification algorithm. So I bring my decision tree classifier, and I say my max of depth where I want to be 1. It means that I just want to branch out the tree once. Later in the video you will see what that means better. And then I say my first part of the data is going to be my whole divorce DF except for the last column. So I drop that column and I input that part of the data frame. And my target or dependent variable is going to be divorce, that one column. So once I create this, the module and the algorithms finds this decision tree to tell you, about the patterns in the data, that the people who answered to Q18 0 or 1, if it was true, they were more likely to. They were more likely to be divorced. You can see 3 cases were not divorced, but 86 cases were. 3 cases were divorced, but 86 cases were not divorced. And then if the answer to this question was either 2, 3, or 4, then the case was a case of divorce. So now it becomes interesting to see what question 18 is, right? So now we go back to the question DF, which is our database of the questions. We'll call it to see what that is. It is, my spouse and I have similar ideas about how marriage should be. So this decision tree says if the answer to this question were more likely and always, it leads to divorce, and if it's not, it doesn't lead to divorce. So yeah, it's surprising and it doesn't make sense. And what I have found about this dataset is actually this dataset is not a correct dataset. It's very surprising to see a dataset like this that doesn't make sense. Its output, its data, it's out there. A lot of people, if you go scroll in the internet, there are a lot of pages that are referencing this data and say we are predicting divorce by 90%, 95%. but no one ever sort of like spend the time to see if the values in this data actually make sense. So I mean, let's just say we didn't look at this. Let's sort of continue, and you will see actually most of the values in this data is sort of like the opposite. I mean, every time it sort of like makes sense to be divorced, it's the other way. So let's assume that we don't care about the fact that it sort of like doesn't make sense. So sort of like, make this about learning about decision trees. So now I want to remove this max depth of 1. So I want to like let the decision tree just does its things. Whatever you want to do, go ahead and do it. So I do that, and then the decision tree becomes a little bit more complex or deeper. So it uses quotient 18, quotient 26, and quotient 40 to answer this. So basically, there is this split. So this is the first split, and then on the here, if this condition is true, you have the second split, which is based on quotient 26, and then you have another split based on quotient 4. If here, for example, quotient 26. So let's see what quotient 26 is. I know my spouse's basic anxiety. So basically what this is saying is that if you don't know, or you say you don't know your spouse's anxiety, you're more likely to be not divorced. And if you do know it, you're more likely to be more divorced. And then quotient 40 is, let's see what it is. We're just starting a discussion before I know what's going on. So if your answer to this question were more often, always, or more likely this happens, you're more likely to, be divorced, or like, the couple is more likely to be divorced than not. So this is the decision tree, right? So the decision tree, what the decision tree did, basically found 3 of those questions based on the mechanism of the decision tree, based on whatever it is that's happening inside. We are not covering that now. But based on whatever it is in that decision tree, in that algorithm, it found these 3 questions as way that sort of like has a relationship between these 3 questions and the labels of all these 170, right? So based on these relationship, this decision tree is sort of giving you an idea of what's happening between these couples. So now you basically fit this model to this data. You can see this model fits pretty nicely here. You can see 81 to 0. So if the answer to this question is false, or the condition is false, is sort of like revealing a lot of divorce, and so on and so forth. I mean, there is no sort of like impurity in these leaves. Basically, I'm using some language of decision tree. So basically, it means that these leaves, or these end branches, are of one label. You see, all of those values are not divorce. You see, but this one is not pure because there are 3 of them that are divorced, but 86 of them are not divorced. If you watch or like learn decision tree, you know what I mean better than. But that's beside the point. What's the point is here is that the algorithm, the classification algorithm, finds the relationship between these independent variables with the dependent variables, and sort of like package this relationship, this pattern, to you to be able to use for classification. So let's say we have a new person, sort of like a new couple. So they come and we ask the following, ask them how much they agree about these following questions. And for example, we ask Rohan Frey, and they say always to the question 18, and always to question 26, and never to question 40. And then we bring these answer to this sort of like packaged pattern. That's what they call it. And then it gives us an idea based on the knowledge or pattern we have found from this 170 data, what we expect for happen to this new data object. So before ending this video, I want to take a minute to sort of like show you sort of like why this data set, the labels should be the opposite. So for example, if you group by divorce on Q40, you will see that if they have answered yes most of the time, it means they are more likely to divorce. And you can do the same for all of the columns. So if you scroll down on all of these, for example, like question 4, when I discuss with my spouse to contact him will eventually work. The time I spend with my wife is special for us, right? And if there is more always, it's leading to more divorce. Or the people who have said always this happens, they are more likely to be divorced. So this if you scroll down, most of these are like that. So this is raise a very serious suspicion in my head that the integrity of this data, or like this data, is actually collected with rigorous manner. So one of the things that in one of the lessons I intentionally included this data to sort of like also include this lesson, that there is this new phenomenon that people just look at the data and just apply an algorithm, right? The algorithm works. It's sort of like predict, but the data doesn't make sense. So if you go through the internet, there are so many different pages, different people who have used this data with catchy titles. Predicting divorce by 90%, 95%, but the data seems to be mistake. So that's one thing you want to take away from this video, to sort of like never just start applying an algorithm to your data, and also paying attention, sort of spending time to get to know your data and seeing if those patterns that are found by your algorithm actually make sense. And but it was a good starting video for you to sort of make sense of classification algorithms.